Now, if we talk about एक का टॉपिक बहुत ज़्यादा सुविधा तो हम स्क्रीन लगाएंगे और यहाँ डी मैकेनिक्स आ गया और हमारी एक्सप्लेनेशन निकालो उसको आप थोड़ा दूसरे
वहाँ से दिखता ही सर हम दोनों लगाएंगे मॉस लगाएंगे.
Okay, next is stability. Stability, we have two things. First, two topics are mainly in stability. Number one is HURWITZ criterion. Number two we have the graphical approach of stability of the root process. Very important topics. But first is very simple. Even a layman can understand. ठीक है, उसको अच्छी तरह समझना है. पिछले जितने भी ग्रेड के क्वेश्चन आए हैं बिल्कुल सिंपल क्वेश्चन आए इस पे. अभी एक वाला क्वेश्चन इसमें भी आता है, समटाइम्स 1 समटाइम्स 2. ठीक है, बोथ ऑफ देम रूट लोकस 2 to 3. Anyway, let's talk about the stability. See, whenever we are talking about the stability can be defined based on the point of view, based on the perspective, based on the conditions. ठीक है, stability को हमेशा ऐसे नहीं डिफाइन कर सकते. So based on some perspective, based on some conditions, or based on certain point of view. Now we will be confining ourselves to time invariant system. What's that called? We have already talked about this. Time linear and time invariant system. So our syllabus confines to linear time invariant system. Okay, so we will confine ourselves to this. Now first, if we summarize about, if we are talking about the stability, let us summarize about the definition of this linear time invariant system based on the natural response. First we talk about the natural response. Now, as we know, if we have a natural response in front of us, a system is stable, number one. If system is stable, if natural response approaches to 0, and then time will approach to infinity. How we say that system is stable? Number one, natural response approaches to 0 and time approaches to infinity. So that system we call this system as a stable system. But when we are defining in terms of the natural response, so what will happen? The response will reach approach to 0 once the time will approach to infinity. Now when the system will be said to be stable, if natural response approaches to infinity and time approaches to infinity also, then we call that system as an unstable system. That's considered unstable system. Now third system we have talked about, that was a marginally stable system. What was a marginally stable system? In the case of the marginally stable system, response will neither decay nor it will grow. It will keep on oscillating. मैंने दिखाया था आपको एक system जहाँ पे, if we have talked, if we remember that time domain analysis, we have seen that if real part was there, that will be responsible for the exponential decay. And then imaginary part is there that is responsible for sinusoidal natural oscillation. So marginally stable system, what is going to happen? In this system, response is neither going to decay nor it is growing, but it will keep on oscillating and it will remain oscillating and remain constant. Okay? So we can write down a system is marginally stable if the response neither decays, or grows, or neither, then it is not or nor grows, but it will what will happen? But remains constant or it oscillates. That means it will oscillate like a sinusoidal curve. Remains constant or it oscillates. This is going to neither decay, neither grow, but it is going to remain a constant. Constant means here we have oscillations, sustained oscillations. We have seen last time like this. There is no damping, there is nothing. Undamped system we have seen. So that's the marginally stable system. When we talk about this system, then we say that this system is a marginally stable system. So this was a definition based on the point of view of the natural response. Okay? Simple. If the system is stable, then what has to happen? Natural response has to become zero, time will become infinity. If it is unstable, natural response will become infinity, time will also become infinity. If it is marginally stable, then it has to remain constant, it has to oscillate somewhere. The damping will not be there and it has to oscillate continuously. And it is neither going to exponentially decay, nor is going to grow. It will remain there, whose amplitude is not going to vary. That's a simple definition. Number two, let's use the definition on the basis of total response. The total response, we have two definitions. Number one, if we are providing a bounded input, then that is going to provide us a bounded output. So we call a system is stable if every bounded input will provide, or that will yield a bounded output. System is stable if every bounded input will yield or provide bounded output. What is the meaning of this? Bounded means if I have a function like this, it's a simple example. If I have a function like this and I am putting a value x equal to 0, then f of 0 will be 3. So I am providing a bounded input, that is defined input. I am going to get a defined value also. Sometimes what is going to happen? Okay, now I have x square plus x, let us say I have something. Okay, now what I am going to provide? I am going to provide a bounded input, but what I am going to get? I am going to get a bounded. I am not going to get a bounded output. That means this is unbounded. It is beyond the. That means unbounded means whose value is not prescribed value, defined value. Infinity cannot be defined in terms of the stability curve. So second is, a system is unstable if bounded input yields an unbounded output, and this is an unbounded output. So system is unstable if every bounded input yields an unbounded output. So I think the meanings, the terms are very clear, what's a bounded and what's an unbounded. Now, this was about the stability about the two things. We have defined stability in terms of natural response, we have defined the stability in terms of second, total response. Now, third, if you recall, study of when we had the poles on the, what is the poles on the left hand side of the RH plane or the S plane means? What does that mean? क्या मीनिंग था उनका जो हमने पढ़े थे उस टाइम? go back to the damping topic. So if we recall, if we have poles on the left of the S plane, then we have seen that either they were exponentially decaying or, okay, the poles we had on the left of the S plane, they give what type of response? Either an exponentially decaying or we had a complete damped sinusoidal natural response. We had either, see on the left hand side we can have poles, we can have on the left hand side of S plane. This is what S plane. This is what stable side of S plane. This is sigma, real axis, negative real axis. This is imaginary. This is minus imaginary axis, and this plane we call as S plane. So on the left hand side, if we have poles, they were lying on the left hand side of the S plane, then what was happening? Either we will get a response, what type of response? Exponentially decaying, or we can also get a sinusoidal, damped sinusoidal natural response we were expected to get. So let us throw some more light on this stability. Number one, how can I set a stable in terms of the poles? Let me define the stability. Okay, थोड़ा सा इसका basic का background, then we go to the HURWITZ criterion after that. Although it's not required, but you should have a knowledge which sometimes पूछ लेते हैं. Now, if I have a stable system, now what's clear in the stable system? In a stable system, for a closed loop transfer function, poles should lie on the left of a S plane. This is the one. So, can I write down this, please? Stable systems have closed loop transfer function with poles only in the left of a S plane. Have closed loop transfer function with poles only in the left of S plane. So this is very clear. So whenever the system we are defined in terms of the transfer function, we have a transfer function, closed loop transfer function. We are having a closed loop transfer function. Then the system will be said to be a stable system if poles will lie somewhere here, not on the imaginary axis also. It should lie somewhere here on the left of the S plane. Number two, we have, now if we have poles on the right half of S plane, what they are going to yield us? नहीं, पहले तो स्टेबिलिटी की बात छोड़िए, वो yield क्या करेंगे? Either exponentially increasing or exponentially increasing sinusoidal natural response. वो भी मैंने कहा, ठीक है? Now how we can define an unstable system? The system will be unstable if the closed loop transfer function has poles. पहले देख लीजिए आप. अगर मेरे if I have poles on the right half of S plane, what they are going to yield us? Exponentially decaying, or we can have exponentially, either if we have a real part, exponentially decaying, or if I have an imaginary part, pure sinusoidal natural response. That is sinusoidal natural response I am going to get in both the combinations. Now, how I can define the stability in terms of if I have a closed loop system? Then if a system has to be system having a closed loop transfer function, unstable system which should have at least one pole in the right half of S plane, then it can have other and or it can have poles of imaginary poles of more than one multiplicity. Are you getting me or not? It should have at least one pole on the right half of S plane, then also and or it can have imaginary poles. That means on the that can have a multiple, more than one it can have. So we can write on second is unstable systems have closed loop transfer functions with at least one pole in the right half of S plane. With at least one pole in the right half of S plane, and or poles of multiplicity greater than 1 on imaginary axis. A closed loop transfer function with at least one pole on right half of S plane and poles of more than one multiplicity on imaginary axis. So this way also the stability can be defined. So there are at least one pole which should have on the right half of S plane, and poles when we have more than one multiplicity it can on the imaginary axis it can have. So what should happen? Poles of more than one or greater than one on the. Now what should happen finally for the marginally stable system? In marginally stable system we have seen neither exponentially grows, neither it decays, it oscillates and remains constant. That's for sure. So what should happen for the marginally stable system? Marginally stable system में a part of the multiplicity of the poles will remain here. So we can write down marginally stable systems have closed loop transfer function with only imaginary axis poles of multiplicity 1, with only imaginary axis of poles of multiplicity 1, that means we'll have poles of multiplicity 1 and poles in the left half of S plane. It will have only one multiplicity pole on the imaginary axis, then it can have the poles on the left of S plane, we don't have any problem. But it should have at least one on the, then only it will be called as margin and this imaginary. It should have at least one here, then we are not bothered. It can have on the left of S plane, we are not. So that would be margin. It's not fully stable, but it's marginally stable. Marginally stable means here one pole should lie. That's all. Simple meaning of this sentence is here one pole should lie, that means on the imaginary axis, then it can have as many as poles on the left half of S plane. So that will be called as marginally stable system. So this was about some small definitions about the system. Let's come to the main topic now. I hope this is clear. So poles, we can define the stability simply in terms of three things. Natural, and I'm not talking about the total response. I'll be talking about the third, which is very important. So number one, we can have poles on the left half of S plane, stable system. We can have poles on the right half of S plane, and we can have poles on the multiplicity on the imaginary axis. We can have at least one on the imaginary axis, that will be imaginary pole on the imaginary axis, one pole, then it can have as many as poles on the left half of S plane. That's called a marginally stable system. This much you have to remember. You don't have to go into the details. Next is HURWITZ criterion. So very important now. That's what the main topic is. HURWITZ criterion is another criterion which reflects something about, which specifies, which will give us information about the stability. How it gives? It will give us information that how many roots will lie on the left of S plane, how many roots will lie on the right of S plane, and how many roots will lie on the imaginary axis. This is what the information is given by it. Then, what is the criteria? How we form this? So we form this, we have to form a root stable. Number one, So what we have to form? We have to form a root table, or we call it root array. Once we form, then we have to interpret this root array. How we interpret it? There is a method behind it, how we solve the remaining terms of the root, whatever we are given. Now, once we solve this, after solving and making the root table complete, I will tell you how to do it completely, but to summarize this first. Once we will form the root, so what is the first thing? First thing about this is that HURWITZ criterion will provide us information about how many roots will lie on the left of a S-plane, right of a S-plane, and on the imaginary axis. This is the number one it's going to give us. Number two, how we have to form this root table. Now we will take a polynomial, characteristic equation of a polynomial we have to take, that may be a closed loop transfer function we have, then characteristic equation of the polynomial we have to take. Once we take the polynomial, we have to form a root array or root table. There is a definite method behind it, that procedure I will come to after that. Then we have to interpret. Interpretation has to be done in such a way that once the first column will be there, then the number of sign changes in the first column of the root array will be the number of poles that will lie on the right of S-plane. If there are no sign changes in the first column of the root array, then there will be no pole on the right half of the S-plane. That means the stability in terms of the HURWITZ criterion is defined. The condition for the stability is valid and sufficient only if there will be no roots on the right half of S-plane. That means all the roots will lie on the left half of S-plane. So let's come to this one. You can write down. The method yields stability information without. The method yields, थोड़ा सा लिख लो, ज़्यादा नहीं है, yields information, stability information without the need to solve for the closed loop transfer system poles. So this method will yield the information about what? Stability without the need to solve the closed loop transfer function poles. That's the number one. This method specifies how many closed loop transfer function or how many closed loop system poles, how many closed loop system poles lie on the left of a S-plane, lie on the left of S-plane, on the right of S-plane, and on the JW axis, imaginary axis. So this is what it will tell. This method requires two steps. This method requires two steps, as I have told you. Step number one, you can write down. Step number one is generate a root table, data table. You can write down like this. Generate a data table called a root table or root array. Generate a data table which is called as root table, or we call it also root array. Some people pronounce ROUTH, some root. Both are correct. We don't know exact pronunciation what his name was, but both of them is correct. So we have to generate a table first. That I will tell you. Number two, then interpret. You can interpret this. Interpret the root array. interpret the root array. For what we have to interpret it? How many roots will lie on the left of first page? We can write down. Interpret the root array to tell how many closed loop poles, closed loop system poles are in the left half of S plane, comma, in the right half of S plane, and in the Z omega axis. Closed loop poles are in the left half of S plane, right half of S plane, and that's what our objective will be. Okay, let me take an example. By example, I will show first in generalization. So you can write down the example. The first step in applying the roots criterion is to form the root array. Okay, that I have already told. So, first step is, for the sake of illustration, a characteristic equation with n equal to 5. For the sake of illustration, a characteristic equation with n equal to 5 is considered. That is a naught s raised power 5 plus a1 s raised power 4 plus a2 s raised power 3 plus a3 s raised power 2 plus a2 s raised power 1 plus a1 is equal to 0. Sorry, this is a2, a3, a4 and a5. Just continue this. You can take any constants. So this is the characteristic equation. N is equal to 5 is the degree 5. So we will consider it. Now form the root array. How will form? Now see. Now comes the procedure. Please understand this. Very simple. This is simplest of the topic in the control system. Root array you have to form like this. See, you have to start from this degree. Whether the degree is odd or even, it doesn't matter. You have to start from this degree. Then take the alternate coefficients. First coefficient is a0, alternate, next is a2 and a4. That will come in the first row. So first row was S5. So what are the coefficients? 3 are there. This is the root array or root table. Alternate coefficients a0, a2, a4. a0, a2, a4. That will be given in every characteristic equation. That will be given in every characteristic equation. Second, S4. This is also given. S4 is how? Then next term is S4 coefficients alternate again A1, A3 and then A5. A1, A3 and A5. I hope this is clear. Now next term, let us say we have to move to S3. How it will be formed? This term will be, you multiply this here, you multiply this minus there divided by 8. So let us say this is B1 and this is, let me calculate on this. Now B1 term, how it will come? B1 is A1 into A2 minus A0 into A3 divided by 8. So you get B. From the ROUTH criterion, how you are going to get the first term? First term you are going to A1 multiplied by A2. From this you have to start from the below. This minus this divided by this. Next term is B2. Now B2 how you are going to define? B2 you are going to define A1 minus A4. Sorry, A1 into A4. A1 into A4 minus A0 into A5 divided by again A1. So this is B1 and B2. Now after that we don't have anything. After that we don't have any term, so we'll put it equal to 0. I think first term is very clear. A1, A2 minus A0, A3 divided by 8. this term, and then second we have talked about B2, whatever you can write here, this is B2, so this term will be A1 A4 minus, this is here, yeah, A1 A4 minus A0 A5 divided by A1. Next we have to continue like this. How? Next term will be S2. So S2, let's see, this is C1. C1 we have to again move from here. B1 like this. So C1 will be, what it will be? B1 A3 minus A1 B2 divided by B1. Okay? C2 how it will be? B1 A5 B1 A5 minus, see here, C2 B1 A5 minus 0 into A1, okay, divided by again B1. So this will, C2 will come out to be B1 A5 minus 0 divided by B1. So this will be A5, whatever it is, we are least bothered, we'll see it later on, but C2 you have to get it like this. Now here after that we don't have anything, it will again come out to be 0. Now S1, next term is D1. D1 will be again C1 B2, D1 will be C1 B2 minus B1 C2 divided by C1. So that is next term will be D2. How it will be? It will be 0. We don't have to write it. 0 and 0. And S0, last term, let's say CD E1. E1 will be what? D1 C2. Okay, like this. This is the procedure. Minus 0, I am directly writing. Divided by D1. And this is C2. So whatever is there, that will always get copied here. E1 will be always equal to this. ये हमें हमेशा याद है. S0 की term, whatever is there, that will be copied and pasted here. लिखने की जरूरत नहीं है आगे से. So this is the way you are forming the root array. Anybody has a doubt? I can repeat it. This is the way you have to remember it. कौन सा बेटा? B1. E1. D1. D1 is this. So we have to do it like this. D1 का कैसे होगा? C1 B2 minus C2 B1, ठीक है, divided by this C1. Is it clear? Now this will continue like this. इनको आगे चलाते जाना है, इसको आगे, इसको इसके साथ, इसके divided. So आगे ऐसे चलाते जाना. Same procedure you have to follow. Now next is, now I hope all the entries are clear in this case. Now what HURWITZ specifies now? Why he has drawn a table now? What he specifies, what the information he is going to provide out of this roots array. The information he is going to provide, that the number of roots of the polynomial that are in the right half of S plane is equal to, I am again going to repeat, write on this. The HURWITZ criterion specifies, the HURWITZ criterion specifies that the number of roots of the polynomial, that are in the right half of S plane is equal to number of sign changes in the first column. That are in the right half of S plane is equal to the number of sign changes in the first column. Okay, पहले इसको मैंने तो बाद में आपको. So Now, what he is telling, ये कह रहा है कि number of sign changes जितने भी first column में होंगे, the number of sign changes in the first column. I will tell you how are the sign changes, how we consider the sign changes. First column of the root array is A0, A1, B1, C1, D1, E1. So the number of sign changes will be there. That will indicate that how many roots of this polynomial will write on the right half of aspect. जितने sign changes होंगे right half में होंगे. अब stability की condition क्या है? Stability की condition, what's the condition of stability? Stability condition for the system will be said to be stable according to the HURWITZ criterion if there are no sign changes in the first column of the root. When there are no sign changes at all, that means system is stable. All the roots will lie on the left half of aspect. So that has to be interpreted. If there are no sign changes, that is equivalent to that all the roots lie on the left half of aspect. You can write on this. The closed loop transfer function has all the poles if the closed loop transfer function has all the poles in the left half of S plane, the system is stable. ये तो हमें पहले से पता है. If the closed loop transfer function has all the poles in the left half of S plane, the system is stable. Okay. Next, for a system to be stable, as per the HURWITZ criterion, it is necessary and sufficient. That each of the first column, that each term, एक term हम मानते हैं, that each term of the first column of the root array of characteristic equation is positive. Of root array of the characteristic equation is positive. That means necessary and sufficient condition for the system to be stable is that these all should be positive. Now let's come to the first. I hope this is clear. Any questions? Take a photograph. Now we need to investigate the stability of the system. So एग्जाम में जो क्वेश्चन आने वाले हैं, नहीं क्वेश्चन सॉल्यूशन को क्या करना है, हो गया? ओके, नाउ ओपन योर व्हाट्सएप ग्रुप. The question is, investigate the stability of a closed loop system whose characteristic equation I am going to write. Mobile phones are now allowed, not for chatting, but to have a look on the question, because it's going to waste some time if I am to dictate the questions also. Now what are the characteristic equation? S5 3S4 7S3 plus 20S square plus 6x plus 15. Okay, so this is the question. As 5 is question को check करना चाहिए हमेशा. 26 is 15. Okay, we have to investigate the stability of the closed loop system. Characteristic equation is given. How we have to investigate? We will investigate by root HURWITZ criterion. Form the root array. पहले दो लाइनें खाली लिखनी है, एक एक लाइन के साथ उसको सॉल्व करते जाना. Don't mess up the thing. S4 में क्या क्या आएगा? कोफिशिएंट 1, फिर alternate 7, उसके बाद ऑल्टरनेट 6, S4 में क्या आएंगे 3, ऑल्टरनेट 20, ऑल्टरनेट 15. Now let's solve this. First entry here will be for S3. What will be 21 minus 20 divided by 21 minus 20 divided by 3. That will be 1 by 3. Okay, 21, 7 3s are 21 minus 20 divided by 3. Next, 18 minus 15 divided by 3. That will be 1. 6 3 is 18, 5 1 15 1 is 15. That will be 3. 3 divided by 3 is 1. Next we don't have, that will be 0. Next term, S square. Okay? 1 by 3 into 20 is 20 by 3 minus 3 divided by 1 by 3. That is 20 minus 9. That is 11 by 3. 1 by 3. 1 by 3. This 3 is, that is 11. ठीक है कि नहीं? 20 by 3 minus 3 divided by 1 by 3. That is 9. 20 minus 9 is 11. 11 by 3 divided by 1 by 3. 3 3 gets cancelled. 11. Next, 15 by 3. Next is this one. 15 by 3 minus 0 divided by 1 by 3. That will be 15. आराम से करते जाना है. S raised for 1. S raised for 1 आगे हम ऐसे चलेंगे. 11 minus 15 by 3 divided by 11. 11 minus 15 by 3 divided by 11. That is 33 minus 15 divided by 33. 33 minus 15 is 18. 18 by 33. Is it clear? Yes, that is 18. 18 divided by 33. That is 6 by 11. Next, this will be 0. लास्ट में मैंने क्या कहा था? इसको सीधा कॉपी करके लाना. करके भी देखेंगे. मैं सीधा इसको कॉपी करके यहाँ लाता हूँ. ये क्या है? This is 15 multiplied by 6 by 11 minus 0 divided by 6 by 11. 15 है. इसको सीधा कॉपी करके यहाँ निकालने की जरूरत नहीं. ओके, आई होप जो हमने बनाया है ठीक है. 1 11 15 6 by 11 and this 40. Now, very clearly at the end, how many changes, sign changes are there in the first column? This is the first column of the room. How many sign changes are there? No sign changes. That means all the roots lie on the left of the fastlane. System is stable. That's what we have to investigate. Whether the sign changes का मतलब क्या? आप छोड़िए. ये तो आपको समझ आया. यहाँ सिस्टम है stable. यहाँ मैं लिख देता हूँ. यहाँ पे लिख लीजिए आप. There are no sign changes in the first column of the roots array. There are no sign changes in the first column of the root array. So there are no roots. So there are no roots with positive real parts, and all the roots lie on the left of a S plane, and all the roots lie on the left of the S plane. And system under investigation is stable. Next, system under investigation is stable. Now next, what is the sign change? अगर क्वेश्चन होता कि यहाँ पे नेगेटिव आ जाता, यहाँ पे नेगेटिव आ जाता. See how sign changes have to be considered. From first to second, yeah, there is sign change. So sign change 1. Again from second to third, negative से positive हो रहा है. Again sign change. There is sign change number 2. Again from positive to negative sign is changing, sign change number 3. Again from negative to positive there is sign change number 4. So there are 4 sign changes which indicates that 4 roots will lie on the right half of a string, hence the system under investigation is unstable. Is it clear? So suppose there was only one sign change, fine. This again is a sign change from negative to positive, yes. Then there was no sign change. So in that case there will be 2 sign changes. So this is the way to check how many sign changes will be there in a root's first form. Let's see, we will talk about that. Now, for example, मैं नहीं लेना चाहता हूँ because sign changes का मैंने बता दिया. I hope sign changes का आपको समझ आया. We will take more examples. Next is what are the difficulties encountered in roots criterion. This is very important. Next is there are 2 difficulties which are encountered in roots criterion. Let's see what are the difficulties. The next is difficulties encountered in roots criterion. So, number 1 difficulty is, see, I will tell you first, right? Very important. Number 1 difficulty is when in any column, in any row, first entry will become 0. See, what will the first entry here will become 0? What happens? This 0 minus this divided by 0. It's very difficult to define the row table after that. You can't define it. So first difficulty is when in any row first entry will become 0. Second difficulty one is, पहले difficulty आपको समझाए, किसी भी row की पहली entry it will become 0. Then it's not possible for us to carry forward the competitions further. नहीं हो सकती है इसके बाद. Second difficulty क्या होगी? Any of the row becomes 0. कोई भी row 0 हो सकती है. आगे कुछ हो नहीं सकता है. So these we have to tackle. Let's see how we can tackle this. We can write. Number 1 is the first element in any one row is 0. Number 1 is the first element in any one row is 0, comma, but the others are not. Comma, but the others are not. The first element in any one row is 0, comma, but others are not. Second difficulty, all the elements in one row of roots area are 0. All the elements in one row of roots area are 0. So let's see now. We'll take an example and then we'll see how we can overcome this difficulty. So you can write down. We are talking about the first difficulty. Difficulty number 1, when the first term of any of the row will become 0. You can write down. Copy karo. इसको क्या सॉल्यूशन भेजने में भी तुम्हारा डिले है. Make it fast. Okay? Have a look at your mobile phone. आपको आ रहा है कि नहीं? आदमी को तो पता ही नहीं, हमने कभी ग्रुप में देखा नहीं होगा, हमें क्लास में लगते हैं. Okay, determine the stability of the closed loop transfer function. Is given closed loop transfer function. What is that? I am going to write it. So this is 10 divided by S5 plus 2S4 plus 3S cube plus 6x square plus 5s plus 3. 5 तक आता है ये एग्जामिनेशन में, 3 is the most common, लेकिन उसमें क्वेश्चन ऐसा नहीं होगा. We'll see the question. Okay, now this is a closed loop transfer function. We don't have to do anything. This is clearly the characteristic equation. Everybody knows denominator. We don't have to explain this. So let's form the ROUTH array solution. S5 again, alternate coefficients will be taken. First 1, second is 3, third is 5. S4 2, 6 and 3. थोड़ा सा मैं पास जाता हूँ. S3 okay, 3 minus 6, 3 into 2 is 6, 6 minus 6 is 0, 0 divided by 2 is 6. Then, okay? Then what? 10 minus 3 divided by 2. This is 5 into 2 is 10 minus 3 into 1 is 3 divided by 2. That is 7 by 2. Rest we don't have. Now, once you are going to do this, what will happen? 6 into 0 is 0. This is 7. That means 0 minus 7 divided by 0 is infinite over there. There are two ways to do it. One of the way I will show you. So what we will do, we will use a term called epsilon. What term? Epsilon. That means the value is 0. We'll write like this: limit epsilon tends to 0 is epsilon. The value is 0, but we'll write it limit epsilon tends to 0 is epsilon. So what I am going to replace? I am going to replace this term by limit epsilon tends to 0, not xi. I think epsilon is like this, right? Epsilon is like this. Okay? Because we are using damping coefficient all the way, so that's why I am writing xi. This is epsilon. Okay, fine. This is 0 again, but epsilon tends to 0. Now we will try to solve this S square. S square is what will be 6 epsilon. 6 into epsilon minus 7 divided by epsilon. So 6 into epsilon, the procedure will be the same. 6 into epsilon minus 7 divided by epsilon. Next term, 3 into epsilon minus 0 divided by epsilon will be 3. You can see 3 into epsilon minus 0 divided by epsilon will be 3. I am writing just for your convenience. S1. S1 will be this term, that is 6 epsilon minus 7 divided by epsilon multiplied by 7 by 2 minus 3 epsilon divided by 6 epsilon minus 7 divided by epsilon. So we'll try to solve this a bit. So this will come out to be 40. This will be equal to 6, 7, 6 are 42. 42 epsilon minus 49 divided by 2 epsilon minus 3 epsilon divided by 6 epsilon minus 7 divided by epsilon. Okay, this is 42 epsilon minus 49 minus 6 epsilon square divided by 2 epsilon multiplied by epsilon divided by 6 epsilon minus 7. Epsilon gets cancelled. So this is 42 epsilon minus 49, okay, minus 6 epsilon square divided by 12 epsilon minus 7. So I am writing this down here. 42 epsilon minus 49 minus 6 epsilon square divided by 12 epsilon minus 7. So this is this term. Now again this will become 0 and this 0 will be 0. This will be copied here. So this we have to copy here. That has been already explained. Why? This multiplied by 3 minus 0 divided by this will be 3. Okay, now how to check the stability? Let's say that this xi is a positive number. Or simply you can say that xi tends to 0. Now here this xi is a positive, we are considering it first positive number. Now 6, not xi, epsilon. This is 0 minus 7 divided by epsilon. Let's say this positive epsilon number is there. So here it is a positive, we are considering it positive. यहाँ पे लिख लेते हैं आराम से. So ये तो problem positive है, इसमें कोई we don't have any problem with this positive. Now the epsilon we are considering positive. Now 6 epsilon is a positive number. So any positive number, anything multiplied by positive will be positive. Positive into positive is positive. Minus 7 divided by, again it's a positive. So it's, but this will come out to be negative here. So this term will be negative. Okay. Again here positive 42 is positive. Minus 49 minus positive square is always positive. Minus 6 divided by 12 minus 7. So this is 40. This will be minus 6 and this will be yes, this will be minus 6 and minus 6 minus 12. Minus 12 divided by 5, but the sign is negative. Is it clear? Okay. This is 55 minus 42. Okay, that is 55 minus 42 is, ठीक है, minus 7 आ जाएगा, minus 7 13 minus 13 by 5, but the sign is we are worrying about sign is negative here only, and this sign is positive. So how many sign changes are there? Sign change number 1. Okay, now no sign change is there. Sign change number 2. So there are 2 sign changes in the first column of the roots array. Hence the system is stable. There are 2 roots on the right half of estimate. There are 2. How many sign changes are there? 2. 1 sign change and then another sign change. So there are 2 sign changes. Okay. So there are 2 sign changes. We can गलती तो नहीं की. ये 42 माइनस क्या है? माइनस 42 minus 49. Okay. 49 is 55. 55 minus 42 is positive है ना? 13. Positive ले रहे ना? 6 minus 7 by okay positive. That is negative sign. ये positive आ रहा है? यहाँ 14 होना चाहिए. हमने गलती की. It should be 14. तो थोड़ी सी गलती से क्या हो जाता है? 14 प्लीज. एक गलती से देखो क्या हो जाता है. Entire question will become wrong. So this is negative also. Sign will be positive. So sign will be positive. Is it clear? थोड़ी सी गलती से you can change the scenario. So sign change is 1. Then sign change is 2, but there is no sign change. So there are at least 2 sign changes. Again 2 आ रहे हैं, लेकिन वो तो गलती से थे. This is very clear. So there are two sign changes, so there are at least two roots. There are two roots in the right half of S plane, hence the system under investigation is unstable. System under investigation is unstable. अगर कोई कहना चाहता है सर पॉजिटिव से क्यों नहीं करें, नेगेटिव से क्यों ना करें, नेगेटिव भी कर सकते हैं, इसमें कोई प्रॉब्लम नहीं है. लेट अस सी, दोनों से रिजल्ट हमें सेम आना चाहिए. ओके, लेट्स से एप्सिलॉन इज नेगेटिव, तो यहां तो कोई प्रॉब्लम नहीं है, पहले में पॉजिटिव है, सेकंड में भी कोई प्रॉब्लम नहीं है, पॉजिटिव है. वैल्यू ऑफ एप्सिलॉन इज नेगेटिव, नेगेटिव, क्या एप्सिलॉन ही हम नेगेटिव ले रहे. नेक्स्ट 42 will be minus 42, then minus 49. नेगेटिव का स्क्वायर तो पॉजिटिव होता है, so that will be minus 6 divided by negative 12 minus negative 14. So how much this is coming? All the signs, whatever the magnitude is coming, this is negative at the top and negative at the bottom. Negative gets cancelled, this becomes positive. Okay, उसको भी देख लेते हैं. Negative minus 6 minus negative 7, ठीक है, divided by negative. So that is negative. Negative ले रहे हैं ना एप्सिलॉन को. Negative minus 6 negative minus 7 divided by negative. So that is again negative at the top, negative at the bottom. This will become positive. So this is positive. This is also positive. This is positive. One sign change. One sign change, two sign changes. So again there are two sign changes in the first column of the roots array. So there are two roots on the right half of S plane. System under investigation is unstable. System under investigation is